In this video, I will show you how to take the graph of a conic section like an ellipse or a hyperbola or a parabola or a circle and come up with the standard form equation. This is an ellipse, a horizontal ellipse. The standard form equation of an ellipse looks like this. We have x minus h squared over a squared plus y minus k squared over b squared, and that's always going to equal to 1. For an ellipse, the x term always goes first no matter what. Now, the h and the k are the center of the ellipse. So that's the first thing we should do, is figure out where the center is. And that's going to be right here. Of course, it'll be in a line with the foci and the vertices, but it will also line up with the co-vertices, so we know it's right here. So this is the point 1, -3. So this is my h and my k. I basically do the opposite of these as I put them into the equation. So because of the 1, I will have x minus 1. Because of the -3, I will have y plus 3. So now I just need my a squared and my b squared. Now the a value is the distance from the center to a vertex. So this is going to be my a value right here, this pink line. Okay, so from the center to the vertex, well, this is from 1 to 9. So that tells me that my a value is 8. Wait, I shouldn't have put a squared. The a value is 8. A squared, of course, then will be 64. So notice that this is a horizontal 8. So I'm going to put this 64 in with the x term. So this is my denominator, 64. All right, I don't know why it's dropping down like that, but you get the idea. If it's a vertical, then I put it with the y term. So speaking of vertical, let's look at the co-vertices. The distance from the center to a co-vertex is the b value. So this is the b value. Notice that this is not right on the line. So I actually don't know the b value right now, so I'm going to have to come back to that later. Instead, I'm going to use the c value. All right, here is a focus. The distance from the center to a focus is the c value. So this 1, 2, 3, 4, 5. So I see that the c value is 5. That means that c squared is 25. If I have a and c, I should be able to figure out what b is pretty easily, because we know that c squared is equal to a squared minus b squared for ellipses. So that means 25 is equal to 64 minus b squared. If I add b squared to both sides and subtract 25 from both sides, right, basically move this over there and move that over there, I'm going to get b squared is equal to 64 minus 25. Okay, so b squared is equal to 39. Is that right? Yeah, so b squared is 39. And that's what I need right here. Notice that the b value is vertical. That's the y direction. So you won't be surprised that I'll put b squared in the denominator of the y term. All right, and I will put 39, not the square root of 39, because we want b squared, not just b. So that is the equation for problem number 1. Okay, now we are also being asked for the co-vertices. So we are going to need the b value. in order to label these. Let me switch over to purple for a second. Look, the x-coordinate of this point is very clear. The x value is 1. However, the y value is 3 point something, and we're not allowed to use a decimal. It has to be exact. So for the y value, you need to start with the center. The y value of the center is -3. So it's going to be -3, and then plus the b value, because I'm going up by the b value. Well, of course, if b squared is 39, that means b is equal to the square root of 39. So that's why we will have -3 plus the square root of 39. Okay, so that is the co-vertex at the top. So I've got 1 comma -3 plus the square root of 39. Okay, and similarly, the other co-vertex will be 1 comma -3 minus the square root of 39. Okay, it's really weird that it keeps dropping down like that. I really don't like that. Anyway, that is how that works.
Problem number 2. What we have here is a hyperbola. We know that the standard form of a hyperbola goes like this. Well, actually, this is vertical. So that tells me that the y term is going to go first. So I'm going to go ahead and put my y minus k squared first. And then it's always going to be a minus right here. And then x minus h squared. And then equals 1. Okay, and then we have a squared and we have b squared. This is the standard form for a hyperbola. And if it's vertical, the y goes first. If it's horizontal, if it were opening like this, then the x term would go first. Okay, so with that in mind, the easiest thing to do is figure out what the center is, because that's going to be my h and my k. So I can tell that the center is going to be right here. This is the point. Okay, the center is the point -2 comma 5. So using the center, I can begin my equation. So because of the 5, I will have y minus 5 squared over something. Because of the -2, I will have x plus 2 squared. All right, I'm doing the opposites. Now, now I need my a squared and my b squared. The a value is always the distance from the center to the vertex. So this is my a value that goes like this. From the center to a vertex, that's my a value. So that tells me that a is 3, which means that a squared is 9. Notice that this is vertical. That's the y direction. So I'm going to put this 9 with the y term. So the 9 goes like that. Now it's time for the b value, the b squared. The b value is the distance from the center to the side of the rectangle that does not have a vertex. So in other words, from the center to a co-vertex. All right, these are the vertices, but these on the sides of this rectangle, these are the co-vertices, like here and here. So from a center to a co-vertex, that's the b value. So my b value is 4, which means that b squared is 16. Because this b value is horizontal, that's the x direction, then the 16 will go with the x term. So that's my equation. In addition to the equation, they wanted us to write the equation of the asymptotes we know that the asymptotes are that pass through the diagonals of this rectangle. So here are the corners of the rectangle here and here. All right, so the asymptote is going to pass through the diagonals of this rectangle like this. All right, and they will go the other way as well. All right, so those are the asymptotes. So for the equation of the asymptotes, it's always going to go like this. It's always going to be y minus k is equal to plus or minus the slope of the asymptote times x minus h. Okay, now this y minus k and x minus h should be looking really familiar. It's the same thing that we just did when we made the equation, the standard form equation. So my y minus k is really y minus 5. I guess I can just start to write this down. Okay, so this y minus k is my y minus 5 is equal to plus or minus. All right, I'm going to leave room for the slope right here. But then we will need the x minus h, which is really x plus 2. So we'll have x plus 2. So all I need is the slope right here, and then I'll be done. Well, look back and ask yourself, what's the rise and the run of this line? Okay, so looking at this segment from here to here, what's the rise and the run? Well, guess what? The rise is the A value, and the run is the B value. So the rise and the run, that's the 3 and the 4. So that's 3 over 4. So that's it. That's the equation of the asymptotes. Let's do number 3. This is a parabola, and it's a horizontal parabola. So I know that the standard form for a parabola is going to be y minus k squared is equal to 4p times x minus h, not squared. This is the version that we use for a sideways parabola. If the parabola were facing up or down, the x would be first and the y would be second. Okay, so the h and the k are the coordinates of the vertex. So let's get that out of the way. So what's the vertex? The vertex is right here at 2, negative 3. So the vertex is 2, negative 3. Okay, so my y minus k is going to become y plus 3 squared. Okay, because that k value is the negative 3. All right, and you kind of do the opposite, so it becomes y plus 3. The h value, that's the 2. So this is going to be x minus 2. All right, now, here we have 4p. Now, what's p? I still need to know what this is. I need to know what p is, so I can get this number right here. So the p value is the distance from the vertex to the focus. Well, man, where's the focus? I don't see that thing. Well, look, the distance from the directrix to the vertex should always be the same as the distance from the vertex to the focus. So this is 1, 2, 3, 4, wait. These are 6 apart. Okay, so if I go 6 again, that will put me here. Okay, so this is the focus right there. Okay, now again, the p value is going to be the distance from the vertex to the focus. So the direction is very important. From the vertex to the focus, is positive 6. So that's why p is equal to 6. If this were going to the left, I would have to say negative 6. So p is 6, which means that 4p is equal to 24. All right, 4 times 6 is 24. So that means this number right here, the 4p, is actually 24. So that's how I know to put a 24 right here. And this is the equation of the parabola. The focus, well, we already found that, but the focus is the point 8 comma negative 3. 8 comma negative 3. Okay, for problem number 4, we are given the general form equation, and we're supposed to write the standard form equation. So first of all, what kind of shape is this? Well, this is going to be a hyperbola. I'm looking at the x squared and the y squared. One is positive, one is negative. That makes this a hyperbola. All right, so in the back of your mind, just remember that the hyperbola goes like this. We have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So this is the shape of the equation that we should end up with. So how do we get there? Well, we need to complete the square. So the first thing I'm going to do is group together my x terms and my y terms. Okay, this 324 is going to have to go to the other side of the equation. Okay, so my x terms. So I have 25x squared plus 150x. Okay, and then I'm going to have the y term. So minus 9y squared plus 108y. And that's going to equal 324 because I moved that on over. So, time to complete the square. Before I go doing half the middle squared, I need to factor the leading coefficients outside of the parentheses. So I'm going to take this 25 and I need to factor it outside the parentheses. So that's going to leave me with x squared plus, and now I'm thinking 150 divided by 25. So that's going to be 5x. I'm going to leave space to complete the square. Wait, that's not true. This is 6. Leave space to complete the square. I need to take out the 9, factor that out. So that's going to leave y squared. Now I'm thinking 108 divided by negative 9. And that's going to be negative 12y, leave some space, is equal to 324. So this is going to be 25. Well, it's not time for that yet. It's time to complete the square. Half the middle squared. Half of this is 3. 3 squared is 9. So I'm going to put a plus 9. But wait a minute. I need to balance this out on the other side. But this is not really a 9. It's really 25 times 9. I'm grabbing my calculator. That's 225. So I need to balance this out with a 225 on the other side. Okay, half the middle squared. Half of this is negative 6. Square it, and that's 36. But this is really negative 9 times 36. So negative 9 times 36, that's negative 324. So I need negative 324 on the other side to balance that out. So this is going to give me 25 times. This will factor as x plus 3 times x plus 3, or x plus 3 squared. And this will factor as y minus 6 times y minus 6, or y minus 6 squared. is equal to. Now, the 324 and the negative 324 cancel each other out. So I'm just going to have 225. We know that the standard form for a parabola has a 1 over there. So I need to create a 1 by dividing everything by 225. Okay. Now 25 goes into 225 9 times. So this is just going to be x plus 3 squared over 9. Okay, I'm probably supposed to write this way down there. So 9 must go into 225 25 times because of what I just saw. So this will be minus y minus 6 squared over 25 is equal to 1. So there it is. This is the standard form equation. Okay. They also asked us for the center. All right. So the center is going to be just the opposite of this and the opposite of this. So the center is going to be negative 3, comma 6. So that's it for number 4.
All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.